Huntington's disease requires one dominant gene for an individual to contract the disease. Suppose that a husband and wife who both have a dominant Huntington disease allele, capital S, and a normal recessive allele, lowercase s, decide to have a child. List the possible genotypes of their offsprings. So for A, we're going to go back to biology class and use a Punnett square. So a Punnett square is relatively simple, right? All you need to do is draw a box, more like a window, right? Because then you got to divide the box into 4 pieces. And you put the gene of the parent, so wife or husband up top, and then vice versa, wife or husband down below. So both of them have a capital S allele and a lowercase s allele. So same thing, opposite side, capital S, lowercase s. So when it comes down to offsprings, their genotypes will cross, and that means each one gets to play a role inside these boxes. So for the first top left corner, we're going to have a capital S and a capital S. Top right corner, we're going to have a capital S and a lowercase s. Lowercase s comes from the parent above, and the capital S comes from the parent across. Bottom left corner, we're going to have a capital S and a lowercase s. Again, capital S comes from above, lowercase s comes from the side. And then finally, bottom right corner, we're going to have lowercase s, lowercase s. So then using the Punnett square, the possible genotypes would be a capital S, capital S, capital S, lowercase s, and lowercase s, lowercase s. Those are the 3 possible genotypes. Now, we don't have to repeat this genotype, this capital S, lowercase s, because they are the same thing. So now, move on to B. What is the probability that the offspring will not have the Huntington disease? In other words, what is the probability that the offspring will have the genotype lowercase s, lowercase s? So to find that, we need the probability of lowercase s, which will be the number of times that could occur, which would be 1, out of the total number of things that could occur. So there's a total of 4 things that could occur. So then the probability of not having the Huntington disease is 1/4, which is the same thing as 0.25 or 25%. So that takes care of the probability. Now, interpretation. Interpretation of this is 1 out of 4 children will not have the Huntington disease. Right? So finally, C, very similar to B. What is the probability that the offspring will have the Huntington disease? Again, to have the Huntington disease, we basically need a capital S somewhere in that genotype. So then the total number of capital S's that could occur, we have 1 here, 2, 3. That's 3. And then there were a total of 4 possible offspring orientations of those alleles. So 3/4, which is the same thing as 0.75 or 75%.